Continuing on with our discussion of the ways you regulate breathing based on the neural controls, we already went through the dorsal respiratory group, DRG, and the ventral respiratory group, the VRG. We need to focus a little higher up now on this Pontine Respiratory group. You have the apneustic and pneumotaxic centers. And those apneustic and pneumotaxic centers are going to help to kind of modify what's occurring down in the VRG and the DRG. So what's happening here now is we're influencing the VRG and helping to kind of change up how the process is working. It's helping to smooth out the inhalations and exhalations. So instead of breathing in abruptly and breathing out abruptly, you slow down the inhalation and then you can slow into the exhalation. Slow down the exhalation, pause, slow into the inhalation. It's helping to really smooth out this process. So you're not having these abrupt ins and outs and these abrupt, it just helps smooth things out so it has a more natural feel to it. So the apneustic center itself, what's occurring here now is it's constantly stimulating the DRG. So you're constantly sending input into that dorsal respiratory group. It's helping to increase the intensity of inspiration. So it increases your inspiratory intensity. While the pneumotaxic center, interesting enough, inhibits the apneustic center. So therefore it promotes expiration. So pretty much it's the apneustic center saying breathe in, pneumotaxic center saying stop apneustic. All right, you can breathe out. Then you have the apneustic center saying breathe in. Then you have the pneumotaxic center saying stop apneustic, allow you to breathe out. So you're not stimulating breathe in and then stimulating breathe out. It's stimulating the inhalation, then blocking that signal, allowing for exhalation. So looking at this, kind of how things are being monitored, at least in that case. So if you have an increase in arterial partial pressure of carbon dioxide, so your arterial blood has high levels of carbon dioxide. Well, what that does is going to decrease pH in the brain extracellular fluid. In there, you're going to have these different chemoreceptors. They're saying, hey, we've got some problems here. This shouldn't happen. But simultaneously, you're also going to have chemoreceptors in the carotid and the aortic bodies. That means you have two different ways you're monitoring this change in the actual chemical composition. What that does then is the medullary respiratory center says, hey, we've got a problem here. Respiratory muscles are going to increase ventilation. You're going to breathe faster, breathe more. That overall ends up putting the partial pressure of carbon dioxide, and for that matter, hydrogen ions, pH, back to normal. That's why sometimes if someone's hyperventilating, the idea is breathe into a paper bag. It forces them to breathe more carbon dioxide back in, which therefore their chemoreceptors are picking it up and saying, hold, we got a problem, slow down. So it's trying to basically give a short circuit to that process by breathing into that paper bag and breathing your own carbon dioxide back in. You're forcing the chemoreceptors to take note in the case of a hyperventilation. But if this happens naturally, maybe you're in an environment that had high CO2 levels or whatever occurred, these chemoreceptors will pick it up, letting your body know, hey, we need to adjust. This is not right. But now that was all happening in the pons and medulla. You have the apneustic and pneumotaxic centers in the pons. You have the dorsal and ventral respiratory groups in the medulla. But the higher brain centers can also play a role. The hypothalamus can actually act through the limbic system. So that means we're talking about emotions can play a part here. Can modify the rate of respiration as well as the depth. Are you breathing shallowly? Maybe 400 to 500 milliliters of breath? Maybe you need to increase that. Pull in 1,000 milliliters per breath. You can modify it based on the limbic and the hypothalamus. Also, you're going to have cortical control to directly bypass those centers if necessary. So even with that base of your brain, that brainstem having this basic function that's in your subconscious, you're not thinking about it, your conscious control can alter it. Emotional state, singing, speaking, swimming. You're going to modify your breathing patterns to match what you're doing. Obviously, if you're swimming, you put your head in the water, you don't want to breathe. But when you come back up, you take a deeper breath than you would have. So you're modifying your breathing pattern to match your swimming strokes. If you're talking or singing, you're matching your breathing, deeper inhalations to allow you to go vocalize a longer range, and then another deeper inhalation. You make sure the inhalations are trying to happen in appropriate locations. Or emotional states. If you're really upset, maybe the breathing increases in that rate. So you have different aspects of your brain, your higher functions, can also control here. And then you have this reflex that no matter how much you want to breathe in deep, you have limitation. Because your rib cage can only expand so far. We have this Herring-Brauer reflex. What's happening here now is, you're looking at stretch receptors in the pleurae of the lungs. As they stretch out, there's a limitation. You can only stretch so far before you potentially start tearing things up. So what happens there then is, it's going to send inhibitory signals saying, hey, stop breathing in, stop inhaling. You've already stretched enough. So if you're trying to take in this super deep breath, there's a limitation of how much air you can take in. You'll notice no matter how much you want to take more air in, you cannot. You're being stopped. Now, this is not a response of everyday casual calm breathing. This is when you take a very deep breath and push your lungs to the limit. It's a safeguard, a way to make sure you can't overinflate your lungs naturally by you moving your muscles. So the Herring-Brauer reflex, a way to kind of safeguard and protect your lungs. So a little about some protection, obviously, from that reflex, as well as some neural control of the higher order of the brain.